So you want to look at the introductory part so that we can simplify. Then from there we should go more into complex Laplace transforms in other series. So usually when you are doing integration, you find that sometimes you get constants in solutions, and under Laplace transform you're going to apply semi-infinite integral. You also apply simple algebra to solve such kind of solutions instead of doing the long and tedious method. So if you have a function f of t where t is defined is greater than or equal to 0, you have a function of t, then t is defined. So if you want to get the Laplace transform of that function, so you have the integral, then t from 0 to infinity, so you have the semi-infinite boundary. So we have exponential negative st, and you have f of t dt, like that. So the Laplace transform f of t is given by t from 0 to infinity exponential negative st f of t dt. So for example, they want you to find the Laplace. F of t is given as 2, then t is defined like that. Your t is defined. Find the Laplace for that function. So you are saying that the Laplace for this one will be the integral from t is equals to 0 to infinity exponential negative st. Then you have f of t. Now we have f of t is 2, so you have 2 dt. When you differentiate an exponential function, find that the coefficient usually goes down. When you integrate, the coefficient usually goes down. When you differentiate, it usually multiplied on the other side. But for integration, the coefficient will go down. So you shall have 2, then you have exponential negative st over negative s, and you have from 0 to infinity. So when you substitute, you have 2 exponential negative s, you have infinity over negative infinity minus, you have 2 exponential negative s, you have 0 over negative s. So this one will give us 0. Then we have this one will be minus, we have substituted with 0 exponential negative s and 0, this one will give us 1. Then we have negative 2 over negative s, which is the same as 2 over s. So the Laplace for that function, we have 2 over s, but you have to define s. S will be greater than 0, then also s will not be equal to 0, because if s is equal to 0, then this function will be undefined. And it should also be greater than 0, because if it is less than 0, then if it is less than 0, then you find that in Laplace we are looking for a convergence. So if it is less than 0, then it will be a divergence. So L of 2 we have 2 over s, so s will be greater than 0, then s will not be equal to 0.